Hi there. So we're trying to use a double integral to determine the volume below a surface. And so in general, to do so, we just integrate the surface over the area. So that would be the integral, the double integral of y times x plus 2 dA. And so what we want to be careful is with the bounds we're using on this integral. And specifically, let's determine what this bottom surface looks like geometrically. So just drawing xy coordinate axes, we have the constraint x plus y equals 0. And so that's just going to look like that. And then we have y equals 1. Again, I'm doing this qualitatively. And y equals square root of 2. And so the contained region is right there. And so what this is telling us is, okay, we have very definitive bounds on y. So we have our outer bounds are going to be from 1 to square root of 2. And now we want to think about what the bounds on x will be. Well, x is between 0 and negative y, if that makes sense. And so, which we're getting directly from the picture I drew on the board. And so the bounds on x will be minus y to 0. And then we have y times x plus 2. And instead of dA, now we have dx dy. And so if we proceed with our integration now, this gives us integral 1 square root 2 times, we're integrating just with respect to x. So this gives us y x squared over 2, just using our power rule, plus 2yx evaluated from 0 to minus y dy. And we are going to need more board space. Now evaluating this, what do we get? We get an integral from 1 to square root of 2. Just our zeros go completely away, so we're just plugging in minus and then plugging in our negative y. So that gives us y cubed over 2 minus 2y squared dy. And so we have one final integral to evaluate. We have square root 2 to 1 of 2y squared, just factoring in that negative sign, minus y cubed over 2 dy. Again, just our power rule. This gives us 2y cubed over 3 minus y to the 4th over 8, evaluated from square root 2 to 1. And I'm just gonna, I actually won't plug this into a calculator. You can evaluate this on your own just by plugging in square root 2 and then subtracting, plugging in v1. And I hope that was helpful.